A polynomial function is a function of the form f of x is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus dot dot dot, meaning to say there are more terms here that we have to insert, but to make it shortcut, it is just represented by dot 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 plus a sub 1 times x plus a sub 0. So a sub 0 here is a constant term. Now take note that a sub n should not be equal to 0. What else? All of these coefficients are real numbers. A sub n minus 1, and a sub 1 should be real numbers. And all the exponents, or n, must be a non-negative integer. So what do we mean by non-negative integers? So these are all positive integers, such as 1, 2, 3, 4, and so on and so forth. And it includes 0. 0 is non-negative integer, so it is possible that the exponent is 0. What else? The degree of the polynomial is the largest exponent on any x term in the polynomial. Later, you will understand this better once we have example on how to identify polynomial. Let me explain further what a polynomial function is by giving you an example. F of x is equal to 3x cubed minus 4x squared plus 2x minus 5. So this is a polynomial function because all the exponents t, 2, and 1 are non-negative integers. So what do we mean by non-negative integers? So those are numbers starting with 0, because 0 is non-negative integer, it's neutral, but it is included here. 0, 1, 2, 3, 4, and so on and so forth. So meaning to say all counting numbers, positive numbers, including 0. What else? Look at the coefficients. 3, negative 4, and 2 are all real numbers. So the coefficients should be real numbers to make it polynomial. So this is an example of polynomial function. Now let me give you an example which is not a polynomial function. 4x raised to negative 4 plus square root of 2x minus 4x plus 2. Looking at this, it's not a polynomial because we have negative exponent, we have square root here, and there is variable inside the square root symbol. When you change this to exponential form, it's the same as 2 raised to 1 half times x raised to 1 half. So there is exponent which is fraction, and fraction is not positive integer. That's why this given is not a polynomial. Now, another example which is confusing, but this is polynomial function. Let's say square root of 9 and then x is outside and you have squared here plus 3x. This is a polynomial because square root of 9 here is a real number because we can get the square root of 9, which is positive or negative 3. That's why this is a polynomial. Now, when you see square root of negative 5x to the fourth, although x is not inside here, but take note, negative 5 is imaginary number. So it's not a polynomial because the coefficient is not real number. Let's have more examples, but this time we're not just going to identify whether polynomial or not, but we're going to find the degree, the leading coefficient, and constant term of each polynomial. Example number 1, f of x is equal to 5 times x minus 2 to the third power times 2x plus 5. This is a polynomial, so it's a yes. Now for the degree of the polynomial, simply look at the x, the values with x, and then multiply. So this will become 5x cubed. Take note that this 3 exponent will be applied to x, so x here will become x cubed. So 5x cubed times 2x will become 10x to the fourth power. Again, so x here is x cubed, then you have 5 outside, so 5x cubed times 2x will become 10x to the fourth power. So our degree therefore is 4, and for the leading coefficient, it's the number beside x to the fourth, which is 10. For the constant term, when you multiply negative 2 to the third power, it's negative 8, and then negative 8 times 5 outside is negative 40. And then negative 40 times 5 here is negative 200. Again, let's repeat that. Negative 2 here is negative 8. Negative 8 times 5 is negative 40. Negative 40 times 5 here is negative 200. So the constant term is negative 200. We're done with number 1. Next, number 2, it's a yes. Now let's multiply x squared times 2x will give us 2x cubed. 2x cubed times 3x is 6x to the 4th power. So our degree is 4 and the leading coefficient is the number beside x to the 4th, so it's 6. For the constant term, looking at this, we have x squared outside. When you multiply x squared to each of the term, then there is no possibility for us to have a constant term. Because when you multiply x squared by negative 3 here, negative 3 will have x squared, so negative 3x squared. When you multiply again x squared by positive 4, then positive 4 times x squared will be 4x squared. So there will be no constant term, so it's none. Instead of writing 0, you have to write none because none is different from 0. So no constant term. Number 3 example, by examining this, we can see that there is variable in the denominator, so it's not a polynomial. No need for us to solve this because number 3 is not a polynomial. Number 4 example, f of x is equal to cube root of negative 8x cubed minus x squared plus x plus 7. Looking at this, it's up to here only. Cube root of negative 8 is negative 2. X cubed is not included here in the radical sign. So simply copy x cubed and then the remaining terms, negative x squared plus x plus 7. So here the degree of the polynomial is 3. The leading coefficient is negative 2, which is the number beside x cubed. So this one is negative 2. And obviously the constant term is 7. So that's all in number 4, and number 4 is polynomial. Next, number 5, looking at this part, unlike number 4, here x is inside, x is included in the radical sign. So therefore, we'll have x raised to 1/3 here, which is a fraction. Therefore, number 5 is not a polynomial. So no need for us to look for the degree, leading coefficient, and constant term because this is not a polynomial.